Welcome to our Meshtastic for Makers workshop, a string of guides where we explore Meshtastic and its practical uses in wireless communications for your maker project. This is sort of the director's cut where we have everything all together in one video, but if you want to watch it in a playlist form or through the written course, you'll find both of them linked below. Welcome to our Meshtastic for Makers workshop, a string of guides where we explore Meshtastic and its practical uses in wireless communications for your maker projects. Traditionally, Meshtastic has been used as more of a hobby or as a method of communicating off-grid. You'd have a Meshtastic device like this, which connects to your phone, and with this setup, you can message somebody else that also has a Meshtastic device. It's a cool kind of text-based walkie-talkie that doesn't need an internet connection or cell service or anything. It is its own network. We are instead going to be using this system to send messages and data between microcontrollers, an essential skill in a lot of maker projects. And this has a lot of benefits over other methods of wirelessly sending data. First of all, it's independent. If the internet goes down, you're fine. You are building your own network. It's also quite long range for how little power it actually uses. Meshtastic uses LoRa, which is low power enough to be run off battery, but still able to send messages several kilometers. It does depend on your setup though and the environment you're transmitting in, but you can get a few hundred meters to a few kilometers. But the biggest benefit is that it's a meshing network, as in each device repeats a message that it receives. So the more devices you have in an area, the better the coverage you get. And you can also work with other people to combine your networks and build a community off-grid network for everyone to use, but we'll get into that later. So over the course of this workshop, we'll be learning a little bit more about what Meshtastic is and how it works. We'll also look at how to set up the Pico on the network and how to actually use it in your projects through examples like sending sensor readings, controlling hardware with messages over the network, and how to connect this network to an MQTT broker. So if you want to have a little fun with some 21st century radio communications, let's get right into it. Welcome to our first video in the Meshtastic for Makers workshop, a short course where we will explore the practical uses for Meshtastic in your maker projects. Before we begin using it, we should probably know what is Meshtastic and how does it work. Meshtastic is a wireless off-grid network that uses the LoRa protocol to allow low-power devices to send and receive messages over long ranges through a meshing peer-to-peer network. Alright, there's a lot of buzzwords there, so let's break down what that actually means. This is a Raspberry Pi Pico. It's a microcontroller and it currently has a LoRa hat on it, which allows it to send and receive information through radio frequencies. And LoRa is pretty special because it really packs a punch. It can send data over quite a long distance while using very little power, ideal for battery-powered projects. Now these have traditionally been used for Internet of Things applications, and you often need another piece of fancy hardware to use it with something called LoRa WAN. It isn't actually that straightforward to reliably send messages from one of these directly to another one. That's where something like Meshtastic comes in. Meshtastic is an open source firmware that you can install to allow your LoRa connected microcontroller to directly communicate with another device, allowing you to easily send a message from point A to point B. A good way to think of it is like a text-based walkie-talkie. When sending messages, you don't rely on any other infrastructure. You don't need mobile data, no Wi-Fi, absolutely nothing. You are building and bringing your own network with these. But it gets even cooler. It's a peer-to-peer meshing network, meaning that if your Meshtastic device receives a message from somebody else's device or your device, it will repeat that message again, extending the range and building a mesh of interconnected devices. And this is really helpful because let's say that I have a device set up on top of a mountain and I'm sending data to it from my home in the valley. That's going to work just fine. Now let's say someone else in my valley wants to send data to their device on the other side of the mountain. The mountain is actually going to block their signal from getting there, but because my device repeats their signal, it will be able to reach it. And then let's say I want to send a signal to the next mountain over. The message will actually hop between all of our devices in the area to reach its destination. And because of this meshing nature, it's really easy to set up lots of devices all communicating with each other and working together. It can be a bit hit and miss sometimes, and there are limitations on how many times a signal can be repeated, but typically, the more people in your area using Meshtastic and the more devices there are on the network, the better the coverage you get. And that is one of the cool things about it. Even if you're only setting up 2 sensors to send data from point A to point B, maybe you're monitoring your chicken door coop and you want to do it from a few kilometers away, you are actually helping to improve the coverage of this extremely valuable community network. And anyone else who sets one up in your area is also helping to improve your coverage. It's a network run by the people for the people. And don't worry, it is all encrypted. If your messages get repeated by somebody else's device, they aren't able to read or understand the information, they're just repeating exactly what they hear without knowing what it means. And although there are public group chat channels that everyone can listen to, you can also create your own private channels for your personal use. On top of this, you don't need a license to operate this, as Meshtastic uses the unlicensed and freely available frequencies in each country. Just be sure that when you set it up, you do set it up for your specific country or region, because it sets it up to use the ones you can legally use. So what's the range of this? Well, it's all very dependent on line of sight. If 2 of these nodes have clear line of sight, meaning that they can directly see each other, you can expect 3 to even 5 kilometers of range, maybe more on a good day. But the more things that you put between them, the less range it gets. Through an urban area with trees and buildings and whatnot in the way, you can expect maybe a few 100 meters to maybe even a kilometer. It varies quite a lot depending on your environment. But if there is a large hill in the way between 2 devices, that might stop the signal altogether, like in our mountain and valley example. That's just a thing of using LoRa, and it's a big reason why this meshing interconnected nature can really help with coverage. And if you want to take it to an extreme level, with line of sight and some serious hardware, people have gotten dozens to even hundreds of kilometers with this. But again, that's using more advanced hardware than you will likely have with your off-the-shelf setup. These antennas that typically come with your LoRa gear will still pack a punch for their size though. And with that, we should hopefully know enough about Meshtastic to start using it. If you want to keep following this series where we'll go through and set up a Pico with Meshtastic, as well as do things like sending and receiving data with it, controlling hardware with messages, you'll find a link to the course page below, and also the YouTube playlist if you prefer to watch it on YouTube in a playlist. Until next time though, happy making. In the last video of our Meshtastic for Maker series, we covered what is Meshtastic. Now let's go and set up a device. There's a limited range of microcontrollers and LoRa modules that are compatible with Meshtastic, and because of that, this series will be centering largely around the Pico and the supported WaveShare LoRa module for it. These 2 things and a micro USB cable to plug your Pico into the computer are the very minimum things you'll need. The LoRa hat will come with an antenna. For this series, we'll be using the regular Pico. There is support for the Pico W if you want to use it, but it's not really as needed in this series, so for our purpose of just sending and receiving data on a project, the regular Pico will do. You also have the option to plug in one of these little OLED screens, which can help with debugging and let you see messages coming through your device, and lets you use it more as a standard Meshtastic device. Again, this is entirely optional, and this entire series will work without it just fine. Now these are the minimum things required, and depending on what you want to replicate from this series, you may need more or less hardware, and we will be covering what you need in the respective videos. Of course, you'll find all the links to everything you need on the course page linked below. Assembly is straightforward. Screw on the little antenna and then connect it to the board. This connector can be a bit fragile, so ensure that it is correctly aligned and then click it in with a little bit of force. A very important note, do not power on the board without an antenna plugged into it, as you can damage it. Once that's done, slot the Pico on top of it, ensuring that you place it in the correct orientation. There is a little marker on the hat showing which side the USB faces. Your LoRa module might also come with this little battery here. It's not very big and it's only enough to power the setup for maybe 12 to 20 hours, but it might be a good option for a backup power. It's not necessary to plug it in, so for now we're just going to leave it. And if you do want to use that OLED screen, go ahead and plug it into the following pins. Now we are ready to set it up. First of all, we need to download the Meshtastic firmware, which you can find a link to in the description below or on the workshop page. Ensure that the firmware version you download is for your specific Pico variant. Once you have that downloaded, press and hold the boot select button on your Pico and plug it into your computer. A removable device should appear. And then all we're going to do is copy that firmware file we downloaded into this removable device, like so. And then the Pico is going to restart and automatically install all the Meshtastic stuff that we need. And with that, our Pico is now running Meshtastic, but before we use it, we need to set up the LoRa module to use the frequencies of our region or country. Now this can be done in a web browser on a computer, or you can also download the Meshtastic app and do it with a mobile device. Just note that you will need a way to plug it into your mobile device, so for my phone I would need a micro USB to USB-C cable. The menus are a little different on the app as well, but it can be set up from a phone, and it's a really handy way of configuring a device out in the field. We will be sticking with the web browser method though, so we'll go ahead and open up a Chromium-based browser, very important there. We'll be using Microsoft Edge, but Google Chrome will also work. Plug your Pico into your computer, don't press the boot select, just plug it in normally, and head on over to client.meshtastic.org. We're going to go ahead and add a connection to a new device. It's going to be serial over the USB connection we've made, and then we're going to add a new device, and I'm pretty sure it is COM port 5. It's most likely going to be a different COM port number for yours. And then we're just going to connect to it like so. Head on over to config, and then we're going to hit LoRa, and then we're going to select our region here. This is a crucially important step, as it will set up your device to use the frequencies and transmission power levels that you can legally use. Meshtastic uses specific frequencies that don't require a license, and this can change from region to region, so it's very important that you choose the right one, or you will likely be breaking the law. And you can see we've got our US bands, our different EU bands, our Japan, Australia, New Zealand, which we'll select, and we've also got Taiwan, India, all the other places. You should check your local area or region to see which one you can legally use. I'll also have a link below on the Meshtastic site for which countries use which. Once you've selected your region, head up to the top here and click Save. And that is going to restart your device and set it up in that frequency. Now, whenever you save a setting like this and your device reboots, you will most likely need to refresh your client page and make that connection all over again like so. And with that, you have your Meshtastic device set up and on the network. Now, if you head on over to Nodes here, you should be able to see a list of all the other devices running Meshtastic that are in range. Now, chances are you may not pick up anyone at first, or it may take a few minutes. This one here that we can see is actually the other device, the test device that I've set up, and we're inside of a warehouse blocking all of those signals, so we're not going to see anyone else. But if you're in a large population center and maybe closer to a window or outside, you might see some people popping up here. And by default, you're going to have this public long fast channel here. This is essentially the public chat that everyone has access to by default, so if there are any people around you, drop a hello in here if you want to. By default, your name isn't going to really be anything meaningful, but you can change it up here like so. You're going to be able to set a long name and a short 4-character identifier like so. And with that, you now have your Pico set up with Meshtastic ready to talk to other devices. As you can see, it really helped to have a second device set up to just diagnose and see if it's all working. But in the coming videos, we're going to start doing things with this, like sending sensor data and controlling hardware with messages, so you can find links to all of them below. If you need a hand with anything from this video, or you just made something cool with it, feel free to drop a post on our community forums. We're all makers over there and we're happy to help. Till next time though, happy making. In this video of the Meshtastic for Maker course, we'll be exploring channels and frequency slots, two very important settings that you need to know before you start sending your valuable data. We're going to be continuing with our Pico, which we set up last video, link in the description if you need that. First of all, let's look at frequency slots. Go ahead and plug your Pico into your computer and then head on over to client.meshtastic.org. Under config and then LoRa, you're going to see the option here to change your frequency slot. By default, it will be set to 0, which sets your device to the default frequency slot of your region. And if you change this number, you will change the frequency your device is operating on. Just so we can see what's going on, I'm using this tool on the Meshtastic site, and as you can see, frequency slot 1 in the Australia region is going to be 915.125 megahertz. But if I were to change over to frequency slot 2, it's going to be 915.375 megahertz. And while this 0.25 megahertz difference might not seem like much of a change, if one device is on frequency slot 1 and another is on frequency slot 2, that slight change in frequency is enough that they won't be able to talk to each other. In fact, they probably won't even know that the other one exists. More importantly, these two devices won't be creating that meshing network together. If a device on slot 1 sends a message, the device on slot 2 is not going to repeat it. They are both sort of isolated from each other on different frequencies, and that is what frequency slots do. It allows you to isolate yourself from other devices on the Meshtastic network. But why would you want to isolate yourself? Well, Meshtastic networks can actually be overloaded if there are too many devices in one area. If there are lots of people in your area using Meshtastic and sending messages all at once, you can actually have too much network traffic and cause kind of a metaphorical traffic jam. This will probably only be an issue in larger cities, and when we say a lot of devices, we mean like a few hundred or so, but it really does depend. So there is an element of responsibility here. If you're going to be sending sensor data a few times a minute and you already live in a very busy area with lots of other Meshtastic devices, chances are you may overload the network and cause a traffic jam of all your messages. In that instance, you should probably think about moving your device to a quieter frequency slot with less or no devices on it. But also be smart about it. If you do live in a busy area and you're only sending maybe a message every hour or less from one device to another, you're probably not going to be putting too much of a load on this system, and you might be able to get away with staying on the default slot. Be responsible, use your head, and maybe even ask the Meshtastic community in your local area what is the good thing to do here. But for the majority of viewers who live in an area with barely any devices, stay on that default frequency slot. There is already a lack of devices around you, and if you change frequency slot, you're not repeating messages and helping to build your local network. There's also one more thing here. You should probably manually set your frequency slot. If you set your device to slot 0, it's just going to automatically set your device to whichever slot is the default in your region. In Australia, if I set it to slot 0, it's actually going to be set to slot 20, which is the default number. So if I set one device to slot 20 and another device to slot 0, they're actually going to be on the same frequency. 0 just sets it automatically, and when I put in 20, I'm setting it manually. We'll talk about it in a little bit, but if you leave it on slot 0, Meshtastic might actually change the slot that you're working on, and that might isolate you from everyone else without you even knowing. So we're going to go ahead, set it to 20 and save it. But remember, the default frequency slot is probably going to be different depending on your region. And in the written course below, we'll have a list of what frequency slot is the default in what region. So go check it out and set that as your slot. All right, now let's talk about channels. So right now, our Pico is able to use the Meshtastic network very happily, but by default, it's going to be using the public long fast channel that everyone in range is a part of. This is fine for a friendly conversation or meeting people over the network, but not for sending sensor data over. So we're going to create our own private channel. This is not only going to protect our data and keep it a little more private if we want, but it's also going to prevent us from annoying everyone around us, because if we're constantly sending sensor data every minute, on the minute, or some sort of automated message in that public chat, this is probably going to annoy everyone in the area very quickly. Now, changing channels is different to changing frequency slots. Changing channel keeps you on the same frequency, and it's more like creating your own private group chat for your devices. Let's say I set up 2 devices in a private channel and a third in the public default channel. All of these devices will see each other and repeat each other's messages, but if I send a message in my private channel, only the devices in that private channel will be able to read those messages. The third device will repeat the message and build the mesh network, but it won't know what the message means because it's not a part of the channel. It just repeats word for word the encrypted message it hears without understanding it. So if you set up your devices in a private channel, you will still be able to see all the other devices in your area. They will still repeat your messages and vice versa, and you'll still contribute to building your local coverage and everything like that. But you'll be able to send messages that only you and other devices that have the details to this channel can read. So to set a channel, we're just going to head on to channel, and here you'll see the 8 different channels that your device can be a part of. There is the primary channel and then 7 secondary channels. Now, unfortunately for us, much of what we will do in this course will only allow us to use the primary channel. This is because the method that we're using to automatically send data is only going to be able to send it through whatever we have set as the primary channel. This isn't really a thing to worry about though. We just need to know that our data will only be sent through whatever channel we have set as the primary one here. So to create a channel, we'll just go ahead and create a name for this channel. We're just going to set Core Demo as our channel name, whatever you want, as long as it's not too long. You also have the option here to create a password. You can leave it as empty, which means it actually doesn't have a password, or you can set an 8-bit, 128, and 256-bit password. Just be aware that if we generate a password here, yep, and we take a look at it, it's going to be a certain amount of characters followed by 2 equal signs. Every password is always going to be followed by 2 equal signs. Just important thing to know. We're just going to leave it on empty because we're not too fussed about our security here. Once you've created a channel, go down and hit submit down below, like that. And if we head on over to messages, you can now see that we're part of the core demo channel or whatever channel name that you've just set. If you want to add another device to this channel, just do the exact same process again with the same channel name and password if you're using one. Also remember that these are case sensitive, so core demo and core demo are two different channels. Now I've gone ahead and set up two more devices here. The test device 2 is actually on the public long fast channel, that default channel, and test device 3 is set up with our private channel. So if I go ahead and send a message from test device 2, we get nothing because it's not in the channel, but if I send one from the test device 3, it says it like so. That public default channel was assigned to the primary channel, so by changing it, we've kind of removed it. And if you ever want to return to that channel, you can do so by entering in these channel details here. Okay, one more little thing, and this is a very important catch. Meshtastic does something a little bit weird if you change the channel of your device. It may also change the frequency slot as well. When you change your channel, Meshtastic might automatically change your frequency slot to help fight network traffic and congestion and all that sort of stuff. The good news is if you set up two devices in the same channel, it is smart enough to set them on the same frequency slot so that they can actually talk together. But because they're on their own frequency slot, they're going to be isolated from everyone else's devices. This is why we said to manually set your default frequency slot for your region. If you manually set your slot, it stays there. If I set it to 20, it's always going to be on 20. Meshtastic will only change it if I set it to 0. When I changed the channel of test device 1 here and test device 3, it actually isolated it and I couldn't see test device 2 here because it was still on the public slot. I had to go into my config, LoRa, and then change them to both frequency slot 20 so that they still remain part of this meshing network. Alright, that was a lot of very important information, so let's quickly recap. 1. If you live in a really busy area where sending messages might cause a traffic jam, change your frequency slot to isolate your devices. 2. You can create your own channel to privately send messages between your devices, but it won't isolate you from other people's devices. And 3. If you do change channel, Meshtastic might try and change your frequency slot, so ensure that you manually set it to the one that you want to use. Do not leave it at 0, unless you just want Meshtastic to decide for you. And as always, until next time, happy making. In this video of our Meshtastic for Maker course, we are going to be learning how to send custom data from a microcontroller to the Meshtastic network so you can send your sensor data, automated notifications, or whatever your project really needs. We're going to be continuing with our Pico, which we set up previously, and please ensure that before you start sending your information, you create your own private channel so you don't annoy everyone around you. You'll find the playlist containing both of those videos in the description below. Alright, what are we doing? Well, we have a Pico running Meshtastic. Why don't we just read a sensor with this Pico and send that data through the network? Well, there are ways to do that, and we might look at that later in the series, but there's only certain sensors that are supported by this native plug-and-play system. And it's not very easy to just write your own sensor reading code and put it on the Pico because it's already running the Meshtastic firmware. Instead, we're going to use a workaround where we have a second Pico working together with our Meshtastic Pico. So this Pico is going to read our sensor data or gather whatever information we want to send, and then it will send that data to our Meshtastic Pico over UART. And then the Meshtastic Pico will be set up to just repeat whatever it hears through that UART connection. If this sounds a little bit tricky, don't worry, it's actually super simple and we'll go through it step by step. And if you've never touched UART before, we have an introduction video linked below, but if you have some level of MicroPython experience, you're probably going to be able to follow along with just this guide. Now, it may seem a little bit annoying to have to use an extra Pico, but it's an inexpensive board, which is why we love it, and this setup that we're doing is going to give you the greatest amount of freedom in your project, and you can really customize it however you want to fit your needs. So to follow along, you're going to need the Pico and LoRa hat we set up previously, as well as another Pico, and we're just going to be using some jumper wires and a breadboard to connect everything together. Now in this course, we're going to be using the Pico and MicroPython as our second microcontroller, but if you want to use an ESP32 or an Arduino or even C++ instead, it is definitely possible. As long as you know how to send UART commands to the Meshtastic Pico, it's going to pretty much be the same workflow. We're just going to be using MicroPython and the Pico in our code along examples. Alright, let's set up our Meshtastic Pico. Head on over to your Meshtastic client, connect your Pico, and we're going to go to Config, and then down here we'll select Module Config. All of these tabs up here are Meshtastic modules, and each one can kind of be thought of as an extension that enables new capabilities for your Meshtastic device. There's some very, very cool things in here that you should check out in your own time, but we are going to be using the serial module. Serial is just another term that people use for UART. So first things first, we're going to enable it, and then we're going to specify our transmit and receive pins. So our receive pin is going to be 9, and our transmit pin is going to be GPIO 8. These are the default UART pins that Meshtastic uses for the Pico, and I would avoid changing them as it will likely just not work. If you do accidentally use the wrong pins, you can also actually soft brick your Pico where it just gets caught in this forever looping boot cycle. If that does happen, in the written guide below, we have a fix for that. Then we're going to set the baud rate to 115,200, and this is just the speed that our UART connection is going to operate at. If you need to change it to something else that your project needs, do whatever you want, but for this demo, we're going to be sticking with this value. And finally, we're going to set our mode to text message like so. Very important on that one. In this mode, anytime that our Meshtastic device receives a UART message, it's just simply going to repeat it and broadcast it to the network. This mode also does the opposite, and if this device receives a message from the Meshtastic network, it's going to repeat it over UART to our Pico. And in the next video, we're going to be using this to control some hardware with Meshtastic messages. And that is all we need to do here, just ensure you hit save. Now let's go ahead and connect everything together. First of all, let's place in our second Pico, like so. Now, unfortunately, that LoRa module we're using has a battery connector on the bottom that makes it difficult to place in a breadboard. To fix this, we're using these header stackers to give it a bit more clearance. You can breadboard without it, but it might be a little bit janky. You'll find a link to these in the description below and in the written guide. Just tack the antenna on the side like so with a little bit of blue tack as well. Starting off, we'll connect a ground pin from one Pico to the other. Any ground pin to ground pin will work. This is just to ensure that they share a common ground. Then we'll need to make our UART connections. We're going to connect pin 8 of one Pico to pin 9 of the other Pico, and then we'll connect pin 9 to pin 8. This means we have RX to TX and TX to RX. Previously, we mentioned that you could connect an OLED to your Meshtastic Pico, and we're going to use this as an opportunity to do so. Now, you can use the standard 1-inch SSD 1306 OLED that you see everywhere, but we're going to spice it up and use this giant 2.4-inch OLED, which is also compatible. It's pretty much the same thing, just scaled up bigger, same resolution and all. Plug in your power pins, and we're going to connect SDA to pin 4 and SCL to pin 5. And if we want to go all the way, we can also plug in a button to let us navigate the menus on this screen. Connect the button from ground to pin 17. Again, both of these are entirely optional, but the more we progress into this series, the more that this OLED can be used to help debug issues, but it's not compulsory. Alright, let's start programming our second Pico. If this is your first time programming in MicroPython and Thonny, or you just need a refresher, we'll have a video link below to get you going. It's real short and it's beginner friendly. We're pretty light on the coding here, so we're going to go through and do it from scratch and explain what does what along the way, but if you want to find the full written out code, you can get that on our course page linked below. So starting off, we'll import the libraries we need, which is going to be obviously UART as well as pin and the time library like so. And then we're going to go ahead and create an instance of our UART. We're just going to call it lowercase UART just for ease of use here. It's going to be using peripheral 1, which is what pins 8 and 9 are plugged into. And then we're going to set our baud rate to 115,200. Make sure that is the same number you set in your Pico Meshtastic baud rate. They need to match. And then we're going to tell our Pico to use pin 8 to transmit on. And we're just going to copy that over, and we're going to tell it to use pin 9 to receive on like so. And then we'll create our infinite while true loop like so. And in here, we're just going to say uart.write, and we're going to send a test message like so. And then we're going to time.sleep for 5 seconds. And this is it. This is the bare minimum code we need to send messages. We create a UART instance, and then whenever we say uart.write, whatever we put in those brackets there, or whatever variable we put there, it sends it to the other Pico via UART, and then that sends the message to the Meshtastic network. And then our 5-second sleep here just means that we're going to be sending that message every 5 seconds. Let's give that all a test. I've powered on our second Pico. By the way, this Meshtastic Pico doesn't need to be plugged into a computer. You can plug it into a a USB wall charger or a phone power bank, or you can even power it through its GPIO pins. It just needs power to operate. I've also got our other Meshtastic device connected to my phone, and if we go ahead and run that script we just wrote, we should see some messages coming through. There is our test message, and it should come through every 5 seconds. Beautiful. And that is how easy it is to send data from a microcontroller to the Meshtastic network. I reckon we're going to go through and do one more example of actually reading a sensor and sending that data on. I think for our example, we'll use a soil moisture sensor. So we'll go ahead and unplug our Picos. We don't want to work on it while it's being powered. And we are going to plug this sensor into power and plug it into our ADC. This is just a very basic analog soil moisture sensor we're using. Plug it back in, like so. So we're going to go ahead and import the ADC library, which we need. Whatever you need to import, you should import up there. And then we're going to go ahead and set up the pin that we will be using for it, which is going to be pin 26, our ADC pin, like so. Beautiful. At the start of the loop, we're going to start by taking a reading of our soil sensor, like so. On side 16. And then we're going to write that reading to our UART connection. Now there is something very important here, which is why we're doing this example. When you read this sensor, it's going to come through as an int or a number. And unfortunately, when we try and write something to UART, it has to be in the format of a string. So if we went ahead and tried to run this code, we can see it's not going to work. So if you are getting a number from your sensor reading or whatever you're doing, you first need to turn it into a string, which can be done with this string conversion line like so. Now if we run it, it's perfectly fine. And if we run this code, you can see that we are now getting that soil moisture sensor data being pushed through. And with this sleep function, we can control how often we want to send that data. 5 seconds is probably a bit excessive. If we wanted to do 10 minutes, we could do 600 seconds. If we wanted to do every hour, we could do 3600 seconds. However frequently you want to send your data, you can set it by just changing the time in seconds here. And that is how you can send any sort of data you like from a microcontroller to the Meshtastic network. You can modify this code to do anything you want, read any sensor you want, perform any calculation you want, but the second you call UART.write, it will be sent via Meshtastic. Well, that about wraps that up. In the coming videos, we're going to go and do some more with this setup and do the opposite, where we receive Meshtastic messages on our Pico and do something with it. If you made anything cool with this, or you just need a hand with anything we covered in this video, you can head on over to our community forums. We're all makers over there and we're happy to help. Until next time though, happy making. In this video of our Meshtastic for Makers course, we are going to be receiving messages from the Meshtastic network onto our Pico and doing things with it like controlling hardware and displaying sensor information. We're going to be using the exact same setup from the last video, which we used to send information. You can find that video and all the others in the playlist below, or follow along on our written course also linked down there. Alright, let's go ahead and start with a really simple example. We are going to control the angle of a servo with messages from the network. Really simple. We're going to plug the power of our servo into ground and VBus, which is going to give us 5 volts, and then we're going to connect the signal to pin 0, which is just what we're going to be using for this demo. We're just going to go through another code along example in Thonny, and there isn't actually much needed to get this going like last time, but to make it really robust and reliable, that's where a lot of the work and a lot of the code comes from. Alright, first things first, let's ensure we have our MicroPython servo library installed onto our Pico like so. We're going to go ahead and import our libraries exactly like we did last video, as well as the servo library this time, and then we're going to go ahead and set up the UART peripheral exactly like we did last time as well. Now we're going to create a servo. We're just going to call it test servo, and that is going to be in pin 0. Oh, equals 0. Then we're going to enter our while true loop, and we're going to start by checking if UART.any in brackets something, something, something. Now, when a Pico receives a UART message, it's going to be held in something called the buffer until we do something with it. And this UART.any, it returns true if there is a message waiting in the buffer for us. So if it is true, we're going to say message equals UART.read, just like that. And then we're going to go ahead and print out that message. Easy peasy. All right, let's give that a test, drag that up. I'm just going to send a test message. I'm just going to send the word test like so. And you can see there's a bit of a jumbled mess, but our message is in there. So what's going on with this weird format here? Well, the B and the quotation marks are something called a byte string. It's just what happens when you use UART. But this weird thing here in the middle with the slashes and the bytes is unfortunately a bug with MicroPython and Meshtastic. The message is meant to be coming through as the 4-letter short name of the sending device, a colon, and then the message behind it. But in MicroPython, we get this big jumble instead of the name. If you're using C++ or another device, that 4-letter code might come through fine, but for us, we're just going to ignore it completely. And to do so, we're going to paste in this big function here. You don't need to know how it works, it's quite involved. All you need to know is that we can send our message to this function and it's going to take out the actual text that we send. It's going to remove everything except for the actual message. And I'm going to print fixed message this time. And if we run this and send a test message, I'm just going to say test, we can see we're just getting our message through nice and beautifully like so. And from this point, it should be as simple as saying test servo underscore write dot, and then the fixed message, which we're going to send a number through. But very importantly, anything coming through UART is going to come through as a string, and we can't put a string as a servo angle, so we need to turn it into an integer before we start using it. All right, we should be able to run that, and I'm just going to send a number from my phone, which is connected to our other Meshtastic device. I'm going to send 180. And the servo gets set to 180. If I send 0, it's going to be set to 0. Oh, how awesome is that? And I should be able to pretty much set it as frequently as I can send messages. There's one more thing we should put in this, and that is error handling. This is probably going to be the most difficult part of setting up something like this in the real world, because let's say I set this up on a mountain a kilometer away, and I'm going to send, instead of a number, I'm going to send actually a letter and a number like so. And I send that, and it crashes. And now we need to make a trip out to our Pico to fix this or restart it. A really handy tool to help prevent things like this is the try except function. So we're going to try to do something, and we're going to nest this writing the servo angle in like so, and then we're going to accept. This is if we try to do something and it fails, we're going to do something else, and we don't actually want it to do anything, so we're just going to say pass, which is do nothing. So now we get our message, we try and write it to the servo. If it works fine, we move on. If it fails, we just don't do anything and we move on as well. And I run this code, and if I go T5 instead of maybe accidentally writing 45, nothing happens. And if I write 45, it gets set to 45. Beautiful. And of course, we used a servo with this example, but this could very as easily be a linear actuator or a motor being turned on, a solenoid lock, a relay flipping some other device, a light or LED, whatever your project needs, you can now control it like so. Now that's great and all for a simple setup with, maybe device A to send data and device B to receive that data. But what if we add some more into this mix? Well, this is where things might start to get a little bit tricky. I have another one of these here. It's exactly the same, just with a smaller screen and a bit of a DIY antenna solution on a pencil there. And if I send them both a message with a number, they're both going to receive that and set the servos accordingly because they're both running the exact same code. We probably don't want that, so we're going to need to devise a system to individually control them. We are going to go through an example of a really simple system for this. We're going to send a sort of topic or identifier before the number. So if we wanted to set the angle of our first device, we might send servo A and then a colon and then the actual number. And if we want to send data to the other one, we're going to go servo B, colon, and then the number. So with that system in mind, let's go ahead and modify our code to match that. So we're going to read the message exactly the same, fix it up exactly the same, but here we're going to say something really cool. We're going to say if fixed underscore message dot starts with, in brackets, and we're going to say servo A, colon, like that. This is going to be the bread and butter of most of this dot starts with function. We essentially put something in there, and if it starts with it, it's going to do whatever we put inside of it. Really simple and a really helpful tool. So inside of this if statement, we're going to put our try function. And I'm just going to go ahead and move it around. There's something very important we need to do because it's going to have that first bit and then the actual number we need. We're going to need to strip off that first bit. And we can do so with that .split function here, which is going to take our fixed message, cut it after the colon, and then we're going to grab the second bit of it, which is going to be the actual number we want. And then just so we can see what's going on, I'm just going to pop in a few print statements here and there, just to help with maybe a little bit of debugging. Ooh, where are we? As usual, I have forgotten a semicolon on an if statement, and we should be able to run this. And then I'm going to send servo capital A followed by an angle, and our servo is going to be set like so. But if I send any other message, any other number, any other even combination of something followed by a colon and then a number, it's going to be ignored like so. And I've gone ahead and uploaded the same code to this one, except instead of servo A, it's looking for the name servo B. If I send servo B, that one gets sent, and if I send servo A, only that one moves like so. And you can see from the screens that they are both actually receiving those messages. Now this is just the system we're using here. I'm not saying you need to use it, it's just probably the simplest way. You should do whatever your project needs. This whole planning and organizing the messaging system across your network might actually be the fun aspect of your project and, you know, worth overdoing just for the fun of it. All right, let's do one more example, something really practical. We are going to build a little dashboard with this giant SSD 1306 OLED screen, and this is of course going to work with the smaller one you might encounter more often. On the course page, you're going to find the sample code for this. It's a bit too long to code along with and write live, so we're just going to paste it in like so. We're also going to install the required SSD 1306 library like so as well. And we're going to go ahead and plug in our OLED screen. Now, you could very easily have another one, but we're just going to repurpose the one from our other Meshtastic Pico and plug it into pins 4 and 5, SDA into 4, SCL into pin 5. Now there is quite a lot going on here, but I've kind of just expanded on what we just wrote beforehand. So we import everything we need, we've got our UART set up, and then we're going to go ahead and set up our screen basically. This is just from the SSD 1306 library. Now something this code does is that it remembers how long it's been since we've actually received that message, and that's all stored in this dictionary called last updates. Then we have our process UART message, which just extracts the actual message, followed by 3 more functions which are to do with timing and writing on the screen and whatnot. You can kind of just ignore them. They just work. Then we turn on our screen and start recording time and finally come into our while true loop. In our main part of our code, it's actually pretty straightforward. We go, if there's anything in the UART, we'll get our message and sort it out nicely. Exactly like last time, we're going to start by saying, does it start with something that we want? And if it does, we're going to take the value behind the colon. Then we're going to start recording time so we know how long it's been since we've retrieved that info. And then we're going to call this function which displays it onto our screen. We've got 6 different possible rows that we can write to because that's how much text we can fit on this screen. And here we're saying we're going to fill in slot 1. We're going to call this reading soil 1. It could be really whatever you want as long as it fits. And then we're going to put through the value, which is what we pulled out after the colon. And if you go down here, we just have 6 of these in a row. Here are the 6 things we're looking for. We're saying if it starts with soil 2 or humidity or temperature or front gate, whatever we're looking for, we're just going to send it to the appropriate slot that we want. And we can go ahead and test that by sending some dummy messages from our other device. So soil 1 followed by some number, and it pops up like so. Let's do a soil 2, beautiful, and a temperature, easy. Let's do a humidity. These are just the ones that I set up before. Let's say it's 89% humidity. It's a really hot day. Rain, let's say 0 millimeters today. And let's simulate a message from the front gate that it is open like so. And just so we can see our whole system in action, I've gone ahead and plugged in our moisture sensor and run the code that sends that sensor reading again. And very importantly, I've gone ahead and modified it so it's sending soil 1 followed by the reading, or our receiving Meshtastic isn't going to know what to do with it. And if I hit run, and you can see our new data coming through like so. Beautiful. I think we need to take a step back and appreciate what we actually have here. We have 2 nodes, one with a sensor that's connected to a Pico, which sends the reading via UART to another Pico, which then transmits that via LoRa that might jump between strangers' devices through several kilometers to get back to our other node, which is sending that message via UART to another Pico and displaying it on the screen. And it's pretty wild that you can make that with off-the-shelf hardware and not much code. And with that, you now have the tools to build some pretty impressive impressive stuff. This could very easily just be a button that turns on a light a kilometre away or something, or 10 gates being monitored, whether they're opened or closed. You could attach one to a vehicle and a GPS to report its location. Or it could be a mailbox sensor on a really large property. Whatever your needs are, we now have a solid method of sending and receiving data wirelessly through the Meshtastic network. And from the snippets of code we've given you so far, it's quite easy to paste them into an LLM like ChatGPT, Claude, or DeepSeek and get it to help you write code and organize your system of sending messages. Well, that about wraps us up for now. If you made something cool with this, or you need a hand with anything we covered in this video, head on over to our community forums. We're all makers over there and we're happy to help. Until next time though, happy making. In this video of our Meshtastic for Makers course, we're going to be connecting our mesh of sensors and whatnot, all of our nodes, to other things via MQTT. We're going to be continuing with the node we set up in the previous few videos, and you can find all of those videos in the playlist below or in the written course also linked below. First things first, let's clarify something. When someone in the more regular Meshtastic community mentions MQTT, they are often talking about network tunneling meshes together. This is where you have a mesh in one place and you use an MQTT server and the internet to connect it to a mesh in another place. There's actually a public MQTT server for Meshtastic devices. We are not doing that, we're doing something else. Instead, we'll be connecting our mesh of sensors to an MQTT broker. This is going to create a connection point from our mesh and nodes to whatever else we really want. If you connected it to something like Adafruit.io, you'll be able to monitor your sensor data over the internet anywhere in the world. If you send it to your Home Assistant server, you can start integrating your Meshtastic connected devices into your home automation setup. Whatever you want to do, if it has MQTT compatibility, you will be able to connect your Meshtastic nodes to it. For this video, we're going to go through the example of sending and receiving data with Adafruit.io, but the method we use here can be used for other MQTT things, whatever you need. Now, the regular internet tunneling usage method of this uses the MQTT module in the Meshtastic client, which is actually extremely easy to use, but unfortunately, in our case, it's not going to work. As you might have guessed, we are going to be using the second microcontroller to do this instead. Very importantly, you will need, of course, to use a microcontroller that supports Wi-Fi connectivity. For our code along, we're going to be using the Pico W and MicroPython, but if you want to use another microcontroller and language, it's definitely possible as well. Alrighty, before we begin, we're going to need to install an MQTT library for our Pico, and we can do that by searching micropython-umqtt.simple. Make sure you have the same library. And now we are ready to go. Alright, we are going to paste in the sample code, which of course you can find on the course site linked below, and let's just quickly go through it and see what it's doing. Starting off, we import all the libraries we need, then we go through and just set up some information that'll be helpful later. Most importantly, we have our Wi-Fi name and password, as well as our MQTT details. I'm just using Adafruit.io, punch in your username and password, and then you need to create a client ID for this device. And this needs to be a unique name across the entire network, so pick something that somebody else probably isn't using. Just going to go ahead and call mine Jared Meshtastic Device 1. Hopefully nobody steals that. And I'll type in my key later because it's probably something you shouldn't share with the internet. On Adafruit.io, I've also gone ahead and created a few feeds. We've got Temp1, Soil1, and Light here. And in my code, I've just gone ahead and created that feed name and assigned it to a variable as well. Adafruit.io is pretty intuitive to use, but if you do need a hand with it, we'll have a guide link below. And that guide is actually what most of this video is based upon. Then we go ahead and set up a UART exactly as we did last time, and we're also just going to set up an LED, which is going to help us with some debugging. Then we get to the first of many functions we'll be using. This one is simply one that connects your Pico to your local Wi-Fi network using the details we used before, and just to help when it's deployed in the field, it's going to flash that LED while it's connecting, and once it's connected, it'll be a solid green. Then we've got our process UART message, which has been in every code we've used before. This is just simply going to take the message and extract out the actual text we want. Nothing really different here. And then we have this MQT subscription callback. And what this is going to do is whenever our Pico receives a message from our MQTT broker and something that it's subscribed to, it's going to do whatever we have in this function here. And just to start off with, we're going to send the message via UART. So when we receive a message from our MQTT broker, we're just going to broadcast it to the Meshtastic network using that UART write that we've been using before. Now here is where it gets a little bit tricky. We're defining an asyncio function. If you haven't used asyncio before, it's essentially a method of getting two separate bits of code to run at the same time. Here's our first asyncio function, and there's our second one. We'll just come back to them in a little bit, and then we actually start running our code. So we'll run the connect Wi-Fi function to connect your Pico to the internet, and then we'll go ahead and set up all of our MQTT information with everything we specified at the top. Then we'll go ahead and set up that callback function as the callback function, and that just means this is the function that we're going to use whenever we receive a message. And then we're going to connect to our MQTT broker and subscribe to the MQTT receive topic, which is light. And then we simply use a Syncio to run handle UART and handle MQTT at the same time. It's a very cool way of kind of running two things at once. So inside handle UART, we have a while true loop, and this is going to be pretty similar to what we've done before. We're going to check, is there a UART message available? And then we'll go through and sort it out and get it into that nice format we've been dealing with. And then we're simply going to check if the message starts with soil1, we're going to do something. And this is exactly like we've been doing before, controlling motors, sending it to the display, but instead we're going to publish it to our MQTT client. And we're going to send this to our soil topic, which at the top here, we defined as soil1. And if we head over to our Adafruit dashboard, you can see we've got our soil1 topic set up, and we've also got temp1 set up. And these are just the topics we arbitrarily created in Adafruit IO to send data to. After that, we simply go through and check, does it start with temp? And if it does, we'll send it to the temperature topic that we set up. Exactly the same thing, and if you want to have more things to be checking for, you can just copy and paste this entire thing again, like so. And instead, you might be looking for humidity 1 or some other message, whatever you want. We've got examples of this from before. And if we run that code, we should see that it connects to the Wi-Fi, and it should connect to our broker real soon. Jumping along. And if I go ahead and send a random message, you should see that it ignores it exactly like we did before. But if I send a soil1 colon and then a number behind it, like so, it should publish it to our MQTT broker. And if I send through another simulated reading, like so, we can see, might take a second, that it updates on our dashboard. And now we can see our mesh and our data from some remote node that might not have internet connection coming through to our Wi-Fi connected node through MQTT to a dashboard or wherever we want to see it online. The second loop that we have running at the same time is this handle MQTT function. And while true, we're going to try and simply check for messages coming from our broker. And the rest of this is just error handling. But long story short, it just checks if a message has come through. And if it has come through, we're going to call this callback function and just write that message to UART. And then because our other Pico is set up to repeat whatever it hears to the Meshtastic network, it'll go from our broker to the second Pico, then to the Meshtastic Pico to the Meshtastic network. And then in our Adafruit IO dashboard, I've just gone ahead and created a button just to test to see what's going on. And if we go into settings, we can see how we've configured this. Edit block. Oh, next. You can see that when the button is on, it's going to send light on, and when it's off, it's going to send light off, exactly in that same format that we've been doing so far, and you should change it to match whatever format you're using. So if we update that, and we save that layout, if I turn this on, we should see a message coming through that the light has been turned on. Like so. Beautiful. And if we flick it off, we can see light on. So that message has gone from our MQTT broker over Wi-Fi to our Pico, then broadcasted to the Meshtastic network, and I'm receiving it on our other test Meshtastic device, and we can see the message coming through here. And if we had a node set up to look for if it starts with light and then followed by on, turn the light on, and if it's off, turn it off, we can now remotely control something through the internet even if it's off the grid. It does just one part of our system needs to be connected to the net. Well, that about wraps us up for now. If you made anything cool with it, or you need a hand with anything we covered in this video, head on over to our community forums. Until next time though, happy making. In this video of our Meshtastic for Makers course, we're going to be looking at how to use the detection sensor module to send the off or on state of a simple digital sensor without the need for the second Pico like we've been previously using. We're going to be setting all of this up on the Pico, which we set up in a previous video, and you can find the entire course playlist and the written course linked below. Now, very important before we begin, let's clarify that with this method, we're only going to be able to send a digital state, so either an off or on signal like a button. This could be a button or or a switch monitoring a gate or a door, a motion sensing PIR sensor, which we will be setting up in this video, an infrared sensor, a reed switch, water level sensor. There are a lot of sensors with a digital output, and that's what we can use in this video. And the trade-off here is that you can only use a simpler sensor, but there is a lot less moving parts in all of this. You don't need a second Pico, and you probably don't even need to code a thing. All right, let's jump into it with a simple button example. We are just going to slot our Pico into the breadboard with the header extenders we've been using so far, and then we're simply going to connect a button from ground to pin 21, which we found to be a compatible pin with this method. Then we're going to open our Meshtastic client and head on over to the detection sensor module. Starting off, we're obviously going to enable it, but then we've got two settings here, and these are different ways of sending that data. The first setting will allow you to send a message when the button is pressed. So only when you press the button will it send a message to the network. And this time here is how often that message can be sent. So let's say we set it to 3 seconds. I press the button, it sends the message, and no matter how many times I press that button again, it won't let me send a new message until 3 seconds have passed. After 3 seconds, I can press it and send another button and start another 3-second timer. And this is really great because let's say it's connected to the door, and as we close the door, it might bounce and tap the button a few times. We don't want to send that message a few times, so by putting a few seconds here, we can stop that from happening. I'm just going to set it to 0 to disable it, and then I'm going to put in 5 seconds for the other one. Really simple, this one. Every 5 seconds, this is going to send the state of the button. If it's being pressed, it'll report 1, and if it's not being pressed, it'll report 0. Very simple, and you can change how often you want this to be sent. This might be a better option if you wanted to know if the gate is open or closed, as you could check the switch every so often. For the rest of this video, we are just going to set this to 0 to disable it, and use the first one here, but it's worth knowing that it's also another option. We're also going to be able to set a friendly name here. Now the message that's being sent is going to start with what we put here and then something after it. If you're using the same messaging system we've been using before, you can put something like front gate, colon, or door, colon, or whatever you need. We'll look at what this output looks like in a bit. Then we're going to set this up on pin 21, which is the one we're using, and then we'll ensure that this top one is off and this bottom one is on. Now the way we have this set up is that when the button is pressed, it will bring the voltage of the pin down to 0 volts or low. Turning off this first setting here triggers the pin to do something when it changes to 0 volts or low. This second one here enables a pull-up resistor inside of the Pico, and this is essentially going to ensure that when we let go of the button, it goes back up to 3.3 volts or high. So then when we press it, it goes down and it goes back up. It kind of springs it back up to 3.3 volts. All right, let's save that and give it a go. My phone is connected to another Meshtastic device and we're just looking at the messages coming from it. And if I press the button, it should come up with door detected. And as you can see, I can press the button a few times and only one message is going to be sent because that 3-second cooldown. And if I press it now, a new message is sent like so. Unfortunately, it does have the space after the colon, and we have been working without the spaces so far because it just keeps it simpler. So if you are going to use one of these and you write code on another node to do something with the message that's being sent from this one, just be aware that it has the space in it and you will need to deal with it. And just for the sake of completeness, I've got the other mode here which sends the message every 5 seconds, and as you can see, it's sending through state 0 because the button's not being pushed, and if I put it down, it's going to be sending state 1. And that's just going to be sending the state of the button every 5 seconds. Now that example was using something called an active low setup, which just means that when we press the button, it connects the pin to ground and brings it down and activates and triggers it. Let's now take a look at how to do the opposite, where we trigger the message when the pin goes to 3.3 volts or active high. Why would we want to do this? Well, with a button, we have the luxury of wiring it up however we want to, but with something like this PIR sensor, it outputs 0 volts when there's no motion being detected, and when it detects something moving, it sets it to 3.3 volts. So we need to use this active high setup. All right, let's wire it up, and we're going to get rid of that button like so, and I'm just going to sit our PIR sensor on the side. Then all we need to do is power it, which we can do by plugging it into the power output pins of the Pico, and then we're just going to ensure that we plug the signal pin into pin 21 of the Pico like so. Super simple, let's plug it in and get to work. Now back in our module settings, we're going to want to turn on the first one because we want to trigger when the pin goes high, and then we want to disable this pull-up sensor like so. And we're also just going to use this as an opportunity to change this to PIR, which is just going to change the message that's being sent. Now most sensors like this do not need a pull-up or pull-down resistor to work. If, however, you are using a button or a switch and you want to use it with this active high mode, you're probably going to need to manually wire one up, because unfortunately Meshtastic at the time of making this video only supports pull-down resistors with software. So if you want to use this method, you're going to make your own. If you do want to use the button, it's probably just easier to use the active low method we just looked at. This active high method is more so for sensors. Alright, I've currently got that running and I'm staying very still so that the motion detector doesn't detect me. And if I move, it should set it to high and send that message like so. And it's only going to send every 3 seconds or however long you put there. And I'm going to stand. Oh, I'm probably moving a bit too much. And move. And it sends a message. And stop. And move. And it sends a message like so. And that is how you can use simple digital sensors to send messages over the Meshtastic network. We are only limited to simple on-off messages, but as you can see, the setup is a lot simpler, and if you get creative, there are a lot of things you can do and measure with a simple digital sensor. If you made something cool with this, or you just need a hand with anything that we covered in this video, feel free to head on over to our community forums. We're all makers over there, and we're happy to help. Until next time though, happy making. And that about wraps us up here. With this, you should have a few different methods and setups that you can use to wirelessly send data via Meshtastic in your Maker projects. I know we mentioned it before, but again, there's something pretty cool here to have your own off-grid LoRa-based peer-to-peer meshing network that can work with other people's if you on the same channel. It's a really incredible thing that we could build something like this nowadays with just off-the-shelf parts. This course was also just one aspect of a Maker project. If you want to go and learn how to use the Pico to its full extent, we have an entire comprehensive course. It's about 4 hours. It's like this. Go check it out. You'll learn a lot. We learn how to plug in a whole bunch of sensors. We go through logic and coding, and we even get into some cool stuff like hosting your own Wi-Fi access point on it. Another thing, this course is a snapshot of Meshtastic as it is in early 2025. If you're watching this video in the far future, chances are there's probably some modules and new things that have been added that you might be able to use in your project. Go and check out meshtastic.org, get involved in the community, and I think I'll leave that as a final line. This is a very community-orientated project. Get involved in your local Meshtastic community. Thank you very much for following along with us. If you made anything cool with this, or you need a hand with anything we covered in this course, head on over to our community forums. We're all makers over there and we're happy to help. Until next time though, happy making.